Hello everyone. So we're picking up where we left off in our last video, where we're still working with a simply supported beam, but this time our vector isn't perfectly straight up and down. It's at a 30-degree angle, as you can see in the video. So this is much simpler than it seems, actually. We're just going to break this vector B down into its components like we normally do for vector calculations. So first things first, we have to set this up as a free body diagram, though. So at A, there's a pin. It's two reactionary forces. Those two reactionary forces are RAY and RAX. You'll notice this time I put my RAX pointing to the left. That's because I'm planning ahead, looking at the direction this vector at B is pointing. I know this is going to have some sort of y component and some sort of x component. And for this sense to be down and to the right, those components are probably going to be pointing down and to the right. So I need something that's going to cancel out this right x direction. So I plan ahead and make this arrow, this vector, point in the negative x direction to begin with. Remember, a roller just has one reactionary force. So we replace that ball with RCY. You all seem to have a good grasp on that when we practiced last time, so we're going to keep rolling. Now we're going to focus in on vector B. So we know that that diagonal vector is a force FB of 100 pounds. So we know that in order to get there, we have to have a y component and an x component. Now these could be on either side. Whatever you draw in your notebook that works for your brain is absolutely fine, as long as your y direction is going negative. It is going down for FBY, and for FBX, it is going to the right, so it is going positive. Remember, with vector calculations, we use a squared plus b squared equals c squared, and sine, cosine, tangent. We are going to have to use that trigonometry sine, cosine, tangent for these vectors. So what we do is first I have to identify what my angle is and how that relates FBY and FBX to FB. So right now, with FB being the hypotenuse, this angle of 30 degrees, FBY is opposite that angle of 30 degrees. So I know that I have my hypotenuse, I have my angle, I'm looking for the opposite, so I can use sine. Sine of the angle is equal to my opposite over my hypotenuse, so SOH. So I translate that to sine of 30 degrees equals FBY divided by FB. Substituting rearranging to solve for FBY on its own. Substituting what we know. And then when you put that into a calculator, it comes out. Make sure that your calculator is in degrees, not radians. 30 degrees, not 30 radians. And you should get 50 lbf, 50 pounds. So we update our free body diagram, label that vector. Now FBX is adjacent my 30 degrees. So I have my hypotenuse, I have my angle. We just calculated this guy. We just calculated opposite. So I don't want to use him to try and minimize any mistakes that I made. I don't want any inaccuracy if possible. So I'm going to just go off what was given to me, which was hypotenuse and angle. And I know FBX is adjacent. So adjacent, hypotenuse, angle, that's cosine. So just like before, we set it up, rearrange to get FBX on its own, substitute in what we know, and then when you plug that into your calculator, again, making sure that your trig is in degrees, not radians, you should get 86.6666666666666666667. We never, ever, 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 ever want to round until the very end if possible. So in this case, we want to make sure we always take that as 86 2/3. So just isolating FB, this should be our little free body diagram. FBY is 50 pounds of force. FBX is 86 2/3 pounds of force. So because we have those components, right now we're going to kind of ignore FB. We're going to replace it in our free body diagrams with FBY and FBX. But there's a quick trick. When we're getting into trusses, you don't want to spend all that time in trig if you can avoid it. There's two special triangles that you can always cheat with these rules. A 30-60-90 triangle and a 45-45-90 triangle. With a 30-60-90 triangle, your hypotenuse is always going to be 2x. Always going to be 2x. Your short side is just going to be x. So your hypotenuse is always double what your short side of your triangle is. And that should be opposite your 30 degrees. And then your other leg that's opposite your 60 degrees or adjacent your 30 degrees, however you want to remember it, is just x times the square root of 3. X times the square root of 3. For a 45-45-90 triangle, it's even easier. Because those are 45 degrees, we know that the two legs have to be equal to each other. So they're both equal to x. Then the hypotenuse for a 45-45-90 triangle is always x times the square root of 2. So 30-60-90 was square root of 3. 45-45-90 is square root of 2. You can always use these rules to help speed things up, since the truss calculation process is a little tedious and long. So you can see we replaced FB with FBY and FBX. Now we have a full labeled free body diagram ready to go for us to solve, just like we did our last simply supported beam. So we're going to start with our sum of the moments, sum of the forces in the x, sum of the forces in the y. So sum of the moments, I have my pin was at point A, so we're going to do moment of B plus the moment of C has to equal 0. Moment of B is equal to the force at B times the distance between B and A. So that's 50 pounds of force times 5 feet equals 250 foot-pounds. And it is going to spin in a clockwise direction, so it is negative. In RCY, we don't know our force, so we know that the moment at C is just RCY times 20 feet. We plug all of that back in to our equation for MB and MC. We rearrange, so that way we get rid of that negative. Divide by 20 pounds to get RCY on its own. And we're left with RCY has to equal 12.5 pounds of force. After we get that, we have to update our free body diagram. We labeled RCY. Now let's do some of the components in the y direction. We know everything in the y direction has to add up and equal 0. So RAY plus FBY plus RCY has to equal 0. RCY we just found was 12.5 pounds. FBY is negative 50 pounds because it's going in the negative y direction, and we don't know RAY yet. So we simplify, and then move it to the other side, and we're left with RAY has to equal 37.5 pounds of force. After we get that, we have to update our free body diagram again. Now, this is where we're different from the last one. RAX isn't equal to 0 this time because we have something in the x direction. We have FBX. So FBX plus RAX has to equal 0. So we remember that FBX is 86 2/3 pounds, and it is going to the right. It is going in the positive x direction. So to move it to the other side to solve for RAY, it has to be negative 86.666666667 pounds. And that makes sense because RAX is pointing in the negative x direction. We planned ahead for that. So after we update our free body diagram, everything's fully solved. We've got RCY, RAY, RAX, and both components of FB accounted for. So you solved your second simple beam. Now, all you have to do is it's these same prospects the whole time. No matter how many forces are on the beam, no matter what angles they're at, you're always going to use trig to break things down into components and use some of the moments, some of the forces in the y direction, and some of the forces in the x direction. You always solve for the least unknowns first. It's the whole process of trusses. Whole process of these simple beams. It doesn't matter if I give you 3 different forces on the beam. I'll do one of those next, so that way you can see what I'm talking about.